Okay, in the last video, we learned how to convert from one concentration unit to another. I gave you a 10% glucose aqueous solution and asked you to convert that concentration unit to molarity. We did that. And we also converted the 10% by mass to molality. In this problem that I have on the board, I've got molarity and I want to convert it to molality. Okay, so here's the problem. There's an aqueous solution of ethanol. Ethanol is C2H5OH, and it's 14.1 molar. Okay, aqueous solution meaning that the ethanol is dissolved in water. Okay, so our solvent is water. The density of the solution is 0.853 grams per mil. I want to know the molality. This is the way I would approach it, and this is the best way to approach these types of problems. You have the molarity, so put units on it. Capital M means moles per liter. Well, instead of liter, I switched it to milliliters, and I just wrote 1,000 milliliters. Okay, so you could write 4.1 moles per 1 liter or 4.1 moles per 1,000 milliliters. All right, the reason I put the 1,000 milliliters is that your density is given in grams per mil, and we're going to be using that to convert volume to mass. So that's what I did. So I have to figure out what's my strategy. What am I looking for? What units do I want to end up with? Well, molality is moles per kilogram of solvent, and we know that the solvent is water, so moles per kilograms of water. Okay, well, the numerator is easy. I don't have to do anything to the numerator. I can basically take this 14.1 and put it over here. So the trick now is to figure out, how do I convert 1,000 mils of solution and get kilograms of solvent? The first step is to use density to convert volume to mass. Once we've got mass of the solution, you know that mass of the solution is mass of solute plus mass of solvent. So if we have mass of the solution and we subtract away the mass of the solute, then we can get the mass of the solvent, right? So that's my strategy. How did I figure out that strategy? I didn't memorize it. I just looked at the units. This is what has to be done. So first step is use density to convert volume to mass. All right. So I've got my density of the solution is 0.853 grams per mil. Put it over here. Mils of solution cancel. And I have 853 grams of solution. Great. Remember, the solution is solute plus solvent. So what I need to do to end up with the mass of the solvent in kilograms is to subtract out the mass of the solute from here. So how am I supposed to know what the mass of the solute is? Well, I know the moles of the solute. So all I have to do is use molar mass to convert moles of solute to grams of solute. So that's what I did over here, right over here. I have 14.1 moles of ethanol. Use the molar mass of ethanol, which is 46.0, and converted my moles and turned it into grams. So I have 650 grams of ethanol. Okay? Now, I know that I have 853 grams of solution, and I have 650 grams of ethanol. So if I do this minus this, the rest is the water. So 853 minus 650 will give me 203 grams of water. I know with this problem it's a little weird that your solvent is less in mass than your solute, which is exactly opposite of what I told you at the beginning, but I didn't make up the problem. It's one of those book problems and I did it, so fine, we'll just go with the flow here. That's how they want, this is what they wanted. So we have 203 grams of water. All I have to do now is convert the grams of water to kilograms of water. Move the decimal 3 places. So now I have 0.203 kilograms of water. I have the 14.1 moles of ethanol that we had right at the beginning. We just throw that here. Moles of solute over kilograms of solvent solvent, boom, we've got our molality. So do the math and you end up with 69.5 molo lowercase m. Okay, so I put this problem on the board to save a little bit of time, but walked you through it. Now we're going to do one together where I've got, what is happening here? I'm going to have molality and I want to switch it over to molarity. Okay, so this one is going to be molality and switch it over to molarity. You can see a pattern here. If you can focus on the units, you can have a strategy and figure out how to go about doing these problems. All right, so here's the problem. We have citric acid. Citric acid is HC6H7O7. This is citric acid. For those of you who will at some point take biochemistry, you may have heard of the citric acid cycle or the Krebs cycle. This is the first product in the Krebs cycle or citric acid cycle, citric acid. So HC6H7O7, this is, I have an aqueous solution and the concentration is 2.331 molo. So this is an aqueous solution. That means the solute is citric acid and the solvent is water. The density of this solution is 1.1346, whoa, so many sig figs, grams per milliliter. And I want to find the molarity. All right, so let's put some numbers here. This lowercase m means I have 2.331 moles of citric acid, HC6H7O7. By the way, the reason this H is in the front, it's just to show you that this is an acidic hydrogen. So they just have it in the front here. You can lump it with the others if you want to. What does molality mean? It's moles per kilogram of solvent. So this number here means per 1 kilogram of water or 1,000 grams of water. So let me just go ahead and change the kilogram to 1,000 grams. 1,000 grams of water. Okay. What do I want to turn this into? I want to turn it into moles of citric acid, so HC6H7O7 per liter of solution. Solution meaning solute plus solvent. So we're going to have to do a number of things here. This number will be the same. So we're going to take this number, put it on the top. So we now have to focus on the denominator. How do I change grams of just water to liters of solution? And this density, I can only use it for the whole solution, not for just the water. So what I need now is I need the grams of solute plus grams of solvent, add them together to get grams of solution. And that's what I'll do first. I'm going to take this 2.331 moles and convert it to grams. 2.331 moles of citric acid, HC6O7O7. Get the molar mass for this, 1 mole. And I wonder if I have it written down here somewhere. It says here it's 192.14, but let me just double check. Okay, carbon is 12. So 12 times 6. Okay, I know that's 72. I'm going to add 1 for each hydrogen, so plus 8. Plus oxygen is 16, and I have 7 of them. So yeah, 192. All right, so 192 grams. All right, so 192 times 2.331 is equal to 447.5. So I'm just going to go 448 grams of citric acid. All right. So I'm going to add the 448 grams of citric acid with the 1,000 grams of water to get the grams of solution, the whole thing. So we're going to go 1,448 grams of solution. You guys see what I did? Because this is the solvent, this is the solute. Solution is solute plus solvent. So we're going to add them together. Now we can use the density to convert grams to milliliters. Remember, density is used to convert mass to volume. So we're going to flip it because this is grams per mil. I want to cancel out grams. So I'm going to put this down here. 1.1346 grams per 1 milliliter. So I'll go 1,448 divided by 1.1346, and I get 1,276 milliliters. So 1,276 milliliters. That's the volume of the solution. So now all I have to do is take the moles divided by the volume in liters, and boom, I've got molarity. So I'm going to do that. See, notice I don't know how to stress this enough. This is not something you memorize. It's just the logical step-by-step procedure. And there are many steps, but one step will lead to the other, if you're focused on the units. If you're the type of student who just wants to memorize everything, this chapter is going to be really hard because you can't memorize these steps. You just have to know, based on the units, what needs to happen next. So we knew to attack this bottom part because this is just the solvent. We ended up getting the grams of the solute, adding it to the grams of the solvent to get grams of solution. We did that, and then we used density to convert it to volume. All right, so now my final step, I'm going to take that 2.331 moles, and I'm going to divide it by the volume of the solution, but now I'm going to switch it to liters. So it's going to be 1.276 liters. Moles per liter is molarity. Everybody see that? All right, so let's go ahead and crunch the numbers. 2.331 divided by 1.276, and you end up with 1.8268. I don't know how many sig figs I'm planning on carrying it to. So let's say we carry it to 4 sig figs. It would be 1.827 capital M. There you go. Okay. All right. I don't know if I have any more. Maybe I'll find one that has a mole fraction and do that, and then we'll be able to switch over to a different topic. Okay.